So for this next example, what we want to do is we're kind of going about it the other way, is we want to find the polynomial that has these four numbers as roots. In other words, that these four numbers, if I was going to graph the polynomial, it would cross the x-axis at 1, -3, the square root of 3, and the negative square root of 3. Okay? Because there are four of these, it looks like our polynomial is going to have a degree of 4. And from there, we're going to get started out. Kind of connect this to synthetic division for a second. What this number means is that with this polynomial, if I put 1 in the box and did synthetic division, that the remainder should be 0. Or if I put -3 in the box, the remainder should be 0. Or the square root of 3 or the negative square root of 3. If I put either one of those numbers in the box, I should always get a remainder of 0. That's what this is telling me when it tells me that these things are roots. Okay? So we're going to go about this backwards. We know that x equals 1, x equals the -3, x equals the square root of 3, and x equals negative square root of 3. And right now you're like, okay, how is this backwards? But just keep following with me. I want to move every single one of these numbers over so it's almost like in the form of something and then equals 0. So I have x minus 1 equals 0, x now plus 3 equals 0, x minus the square root of 3 equals 0, and x plus the square root of 3 equals 0. Well, since all of these are equal to 0, what I'm going to do now is take the product of all of them. So x minus 1 times x plus 3 times x minus the square root of 3 times x plus the square root of 3. All of that equals 0. And let's start right here. If I gave you this as a polynomial right here, and I said find the x-intercepts, wouldn't you just kind of go back to that step and then to that step? So y'all can all see we're kind of just going back this backwards. All we have to do is now is multiply these four parentheses together, and we've got a polynomial. Well, I'm going to kind of do two at a time. So let's go the front two, and let's go the back two. So the front two multiplied together will give you an x squared, let's see, plus 3x minus 1, so plus 2x minus 3. When I multiply the next two together, x times x is x squared. These are conjugates because they're the exact same thing, just the different signs in the middle, which tells me that the outside insides are going to cancel. You'll get a positive square root of 3 and a negative square root of 3, so those go away. And then the last terms is a square root of 3 times the square root of 3, square root of 9, which is 3. Okay, so let's kind of, all we have to do is multiply this front one to this back one, and we can call this thing done. Okay, so x squared times x is x cubed. Give myself plenty of room here. X squared times -3 is a negative 3x squared. And let's go 2x times x is 2x squared minus 6x minus 3x plus 9 equals 0. And then just finishing up, kind of combining some like terms, we have an x cubed, a negative 3x squared, and a positive 2x squared will be a negative x squared. And negative 6x minus 3x is a negative 9x plus 9 equals 0. And if I wanted to write this in polynomial form, I can just say f of x is equal to all of this. Okay, and so what we just found is basically a polynomial that if I started with synthetic division, I wrote out the coefficients of 1, -1, -9, and 9, and I chose numbers to put in the box, as long as those numbers were the original 1, -3, square root of 3, and negative square root of 3, basically what comes out is the remainder of 0 every single time. Alright, so let's go to example 8. We're going to do the same thing. We want to know a polynomial that has 1, 3 plus the square root of 2, and 3 minus the square root of 2 as roots. Okay, so just chose this one to practice on just because the roots look a little more nastier. But exact same process. And I'll kind of walk you guys through this one a little bit so it can get tricky. Let's move that over, let's move that over, and let's move all that over. So we get x minus 1 is equal to 0. Let's go with x, let's see, minus 3 minus the square root of 2 equals 0, and x minus 3 plus the square root of 2 equals 0. So take 2 seconds to make sure you agree with me. Every time you move terms over, all they do is switch signs. Okay? All right, now let's multiply these together like we've been doing. So x minus 1, x minus 3 minus the square root of 2, and x minus 3 plus the square root of 2. And what I want to utilize to make this really easy on ourselves when we go through the process of trying to multiply this together, let's look at these last two parentheses. You see how it's x minus 3 minus the square root of 2 and x minus 3 plus the square root of 2? These are actually conjugate pairs, and they can really help us when we're trying to multiply this together. So I'm going to leave the x minus 1 right there. And we're going to FOIL this. Even though it has three things in there, let's treat it as this x minus 3 is one thing, the square root of 2 is the second thing, x minus 3 is one thing, and the square root of 2 is the second thing. So first to first would just be x minus 3 times x minus 3. If I go outside, it's a positive square root of 2 times x minus 3. If I go inside, it's a negative square root of 2 times x minus 3. And then the last but not least, it's a negative square root of 2 times a positive square root of 2, which is just negative 2. So basically, the reason why I did all of that right there was for this fun part right there. Those completely cancel each other out. A positive square root of 2 of this and a negative square root of 2 of this they completely go away. So really we're looking at negative x minus 1 times, let's go ahead and FOIL this thing out, so x squared minus 6x plus 9, and then a minus 2 equals 0. Or x minus 1 times x squared minus 6x plus 7 equals 0. And then we can finish multiplying this just real quick. So x times everything in there. So I gave myself just a little room for a second, but x times everything in there was, let's see, x cubed minus 6x squared plus 7x, and then negative 1 times everything, so negative x squared plus 6x minus 7. Then all I have to do is combine like terms. Let's go ahead and write it in polynomial form. X cubed minus 7x squared. 7x and 6x is 13x minus 7. Box this up and we are good to go. So again, the whole part with this was this for that step right there and that step right there. That's the whole reason why I chose this for an example for us. Okay, let's wrap this lesson up and look at the very, very last problem right here. We want to determine all of the roots of this polynomial if 2 is already known to be a root. Okay, so 2 is already known to be a root, which basically tells me that if I did synthetic division, I put 2 in that box, I should get a remainder of 0. So let's start with that. I've got a 4 on my x cubed, a negative 4 on my x squared, a negative 11, and a 6. So drop the 4, multiply it in, add it up, multiply it, add it up, multiply it, and add it up. That's a very good sign I got 0 because it tells me that 2 should be a root. Now remember, this right here is just that right there is just the coefficients on the remainder polynomial. So drop the degree by 1, so 4x squared plus 4x minus 3. And all we need to do from here, since this is a quadratic, I know for a fact that we can either try to factor it, and if it doesn't factor, then we can always try doing the quadratic formula. I personally don't want to, I like to try to factor first, but to me it's always the easiest. But if you love to do the quadratic formula, I would say go for it. So let's see. When we start this out, we can try 4 and 4, or 4 and 1. And let's see, if we put maybe the 3 there and the 1 there, that would probably get us the center of 1. So that doesn't look like that's going to work out. So let's try maybe 2 and 2. Let's see what we can do there. And you know, a lot of this is just trial and error as we practice this out. If I put a positive 3 right there and a negative 1, 2x times 2x is 4x squared. The outsides would be a 6. Minus 2 is 4, and negative 3. Looks like we're good to go. So setting each of these equal to 0 is 2x minus 1 equals 0. 2x plus 3 equals 0. Gives me move the 1 divided by 2, so x is a half. And move the 3 divided by 2 is negative 3 halves. So combined with our very first one that we knew, all the roots technically of this polynomial are right here. X equals 2, x equals a half, and x equals negative 3/2. And what I want to show you guys is coming back right here to this step right there. If I truly wanted to factor this, if I wanted to factor this polynomial, the factors would be, go up here to the box, we're going to take the opposite of it, so x minus 2. Up here would be, I guess we can go, maybe we'll go more to the actual written out, as x minus 1/2. And then last one is x plus 3/2. And that right there is that polynomial completely factored using our roots. So pretty cool thing.